Let's talk about some linear equations and linear functions. Oh, we love lines. So if you think about a line is just a collection of points that are all collinear. I'm going to pick two of them. Let's call it x1, y1 and x2, y2. And you might remember talking about the slope of a line. In IB, we call it the gradient of a line. So you might remember that the gradient of a line is when you take the change in the y values and the change in the x values. It equals the slope that we call m. Hey, do you know why we call it m? M stands for the measure. Because if you think about it, we can measure the length of a segment, we can measure an angle. But how do you measure a line if it goes on forever? Well, you can't measure its length, but you can measure its steepness. So we call it m for slope, or for a gradient. How about that? And you probably know the three different forms of a line. My favorite is the point slope or point gradient form, which is where you subtract the y value from y and equals m times x minus the x value. And you might be thinking, where the heck did that come from? Well, if you take a look at this slope equation for a second, if you multiply by the denominator, you get that equation. So it's pretty cool where it comes from. You might also remember the gradient intercept or slope intercept, one that looks something like y equals mx plus b, where b is the y-intercept. You might remember that one. And the standard form is just where the x and the y are on the same side. So we typically go ax plus by equals c, where when we're at a lowercase a, I wanted to write an uppercase a, where a, b, and c are in the set of real numbers. Cool. And if I want to go back really quick to my point gradient one, this here one on the left, I like to write it this way, just because I like to be in a y equals form. But either one is acceptable. Your choice. Doesn't bother me. Cool. Well, a couple of the things about lines that we want to be aware of. If two lines are parallel, their slopes or their gradients are equal. If two lines are perpendicular, their gradients have a product of -1. You might have heard that in a geometry class, that the slopes were opposite reciprocals or negative reciprocals. A horizontal line has a gradient of 0. The slope of a vertical line or the gradient of a vertical line is undefined. So a horizontal line does have a slope. Its slope is 0. It's defined. But a vertical line slope is undefined. Cool. Just some good things. So if you want to take a minute or two and write the equations of these lines that have these criteria to them, give it a shot. All right, so for the first one, horizontal and passing through the point 4, 2. So if you think about that line, it's always going to be a y equals line. Horizontal lines are y equals. So it's going to be y equals 2. Likewise, a vertical line passes through the x-axis, so it's an x equals line. So this is x equals 6. If it's parallel to that line through that point, I'm going to use my gradient point line, my point gradient line with point slope, whatever it is. So I'm going to call that line y equals, it has the same slope. I'm going to go x subtract the x value, so x subtract -5, which is really x plus 5, plus 2. And we can leave it in that form, I guess. Doesn't say anything about that. The next one is perpendicular to this line here. It's in standard form. If I put it in its slope intercept form or gradient intercept form, I can find the slope. So if I subtract the 4x, I get 3y equals -4x plus 10. And then if we divide both sides by 3, and I really don't care what the y-intercept is, I just want to know that the slope or the gradient is -4/3. Now, perpendicular lines have opposite reciprocal slopes. So my perpendicular slope is 3/4. Remember that symbol for perpendicular, the upside down T? So now our equation is going to look something like this. Y equals 3/4 times x subtract 5 minus 7. And I know that there's other ways for you to write the equation of a line as well. I've always felt that if you're given a point and you're given a slope, use the point slope method. If you're given 2 points, find their slope. and then use the point slope method. So that's kind of what we have down here. So I'm gonna need a little bit of more room down here, let's see. So if we want to find the slope of this line first, let's see, the slope is going to be 6 minus negative 3, or 6 plus 3, over negative 1 minus 4. So our slope is negative 9/5. And then if we write it using the point slope form, I'll write y equals negative 9/5 times x. Doesn't really matter which one we use. I'll use the second one, x minus 4 minus 3. Now, we want to put the answer in standard form, which means I want to get the x's and y's on the same side, which means I got to clear out the fraction, which means I got to multiply everything by 5. So this is going to give me 5y equals negative 9. Let's just distribute that. Negative 9x plus 36. And did you remember to multiply the 5 by the negative 3 and get negative 15? And now if we put our x's and y's on the same side, we get 9x plus 5y. And if we combine 36 and 15, we get a positive 21. So there's our equation in standard form. So it's just doing a little bit of algebra at the end. Well, let's keep going. Other things we did were we graphed lines. No, put that calculator down. We're not going to graph with the calculator. So when we graph a line like y equals 1/3 x plus 2, we're going to start at the y-intercept of 2. So the y-intercept is 2. Start at the point 0, 2, and then do the slope. So here's my point. I think I'm going to do a slope of 1/3. So I go up 1 over 3, up 1 over 3, up 1 over 3. And then I can go the other way, down 1, left 3, down 1, left 3. That's a slope of negative 1/3. Let's draw a nice line through that. There's the line y equals 1/3 x plus 2. And I know you're saying, oh, that green line is killing me, man. Well, wait a minute. I know from this that the slope is going to be 2/3. And I know that the coordinates of the point are 5, negative 3. So this is exactly the same as the previous one. Go to the point 5, negative 3, and let's do a slope of 2/3. Up 2 over 3, oh, I ran out of room there. Down 2, left 3, down 2, left 3, down 2, left 3. We kind of get the idea. So there's my green line. As long as I know a point and I know a slope, I'm good. But I don't know either one for the red line. But that's okay. Let's find its intercepts. So if I find my x-intercept, that's where y equals 0. And when y equals 0, and I plug in 0 for y, I basically get 2x equals 12, so x equals 6. So the x-intercept is the point 6, 0. I know the graph crosses right here. And if I do the same to find the y-intercept is where x equals 0. So when x equals 0, I get 4y equals 12, or y equals 3. So the point 0, 3 is the y-intercept. And there's my line. And it looks like it has a slope of negative 1/2, I think, because it goes from there to there. So that's going to help me to draw my line a little bit better. I got some of those points on there, and I got some of those. Ooh, there's an intersection. Cool. And there's another intersection. Cool. Nice. So we can graph lines regardless of the form that they're in. And then we had fun word problems like this. For Color Wars, we need our t-shirt. So PVT sells t-shirts. The initial setup is $30. Okay, so that's like the one-time cost. And they each cost $3.49. So I'm thinking if I got to write two functions down here, maybe I'll say something like that P of x is going to be 30 plus 349x. And Color Wars supplies, of course, you figure there's like a Putnam Valley graduate that's going to sell Color Wars supplies, right? Think about it. Hey, that's a good business model. Okay, there's no initial setup fee, so then C of x is going to just be 3.99x. And then check this out. What we want to try to figure out is how many shirts must be purchased for PVT to be a better deal. So it's a better deal when it's cheaper. So we want to know, when is 30 plus 349x? When is it less than 399x? And that's an equation or an inequality that we can solve. We subtract 349 to the other side. We get 30 is less than 0.50x. If we divide by 1/2, it's like multiplying by 2. So I'm going to get that x has to be greater than 60. So if you're going to buy more than 60, you got to go with PVT. Cool. Hey friends, that's equations of lines. What do you think? Do you love it?